Today, in today's concept, we'll be discussing about partition clustering, which is one of the most discussed concept of machine learning. The most important algorithm in partition clustering is K-means algorithm. So in today's session, we'll be having a discussion on K-means algorithm, how it is being implemented, how we can understand the concept of K-means with a small example problem which we can solve. So we'll take a small data set and try to understand how to compute k-means algorithm and how to form clusters. Okay, yeah. Moving ahead, so partition clustering, as we have discussed, there are three types of partitioning algorithms like k-means, PAM, partition around midoids, which is also called as k-midoids, and next one Clara, which is abbreviation for clustering large applications. Okay, yeah. So this clustering method classifies the information into multiple groups based on the characteristics and similarity of the data. So initially, whenever we are given some unlabeled data, we need to understand each data point according to the centroid calculations. So partitioning clustering basically works based on the centroid-based calculations. So initially, we need to assume some centroid values, and later, according to that particular values, we need to form clusters. It can be 2 clusters or 3 clusters. According to the data set what you're having, we can decide number of clusters. Okay. Yeah, talking about partitioning clustering, suppose we are given a database of n objects and the partitioning method constructs k partition of data. So yeah, whenever you are giving some set of objects, it can be n objects. So as the name suggests, it's a partitioning method. It need to construct k partitions of the data. It's nothing but number of clusters we want to divide is nothing but the k value here. Okay, so each partition will represent a cluster, and k should always be less than or equal to n. So because we are having n objects, the value of k should be always less than or equal to n. So which means that it will classify the data into k groups which satisfy the below requirements. So whenever you're working with a partition clustering, keep a note that each group contains at least one object. So we cannot simply say, for example, I want to construct 5 clusters. But if you are taking number of clusters as 5, and if one of the cluster is empty, it doesn't make sense. So you need to ensure that each group or each cluster contains at least one object. And the next point, each object must belong to exactly one group. So because we are talking about partitioning clustering, which is a hard clustering concept. So whenever we are talking about hard clustering, each data point should belong to only one group or one cluster. So if it is a soft clustering, then we can go for next. Suppose if I say if it is a soft clustering, each data point can be divided into one or more clusters. But because we're talking about partitioning clustering, here each data point or each object must belong to exactly one group only. This is very, very important observation, which we need to understand even for k-means or k-midoids concept. Okay. Yeah. So whenever you're talking about k-means concept, which is the partitioning based clustering concept. So because as I said, we need to have some statistical and probabilistic concepts in our mind whenever you are applying this data mining or machine learning concepts. So even whenever when you want to understand the k-means algorithm, you need to work with Euclidean distance, right? And also some other distance measures. So from this slide, we need to understand that there are different types of distance measures which for which we can apply for k-means clustering. So k-means clustering supports different kinds of distance measures as listed below. First one is Euclidean distance, which everybody of us know because we have applied this Euclidean distance in very, very basic calculations also. So if you are having 2 points x1 y1 and x2 y2, the formula goes something like this: under root of x2 minus x1 whole square plus y2 minus y1 whole square. That is the formula for Euclidean distance measure. So apart from Euclidean distance measure, you can also use Manhattan distance measure, cosine distance measure, and squared Euclidean distance measure. So these are the 4 different types of Euclidean distance or distance measures which can be used in k-means clustering concept. So in our example, we will try to use Euclidean distance concept and explain our example. Okay. Yeah. So this is a pictorial representation or understanding of k-means algorithm. So the picture easily depicts what the data points before k before applying k-means, and what are the data points after the application of k-means concept. So from this picture, we can understand that before k-means, data points are grouped something like this, which are indicated in green color, because there is no separation, there is no label in your data. All points are looking alike. But once we apply k-means, so you can see here you are having three different clusters, because the data objects or points are grouped in accordingly. We are having three clusters. Okay, so you can see one cluster, cluster one is having green color points, other one is blue, and the third cluster is black color points. So how did they form these clusters? So these clusters are computed or formed based on the similarity measures. The similarity measure is nothing but the distance calculation, the distance of one data point to the center. That is what we call it as centroid. So how should we calculate centroid? If you are having 3 points, x1, y1, or x1, x2, x3, y1, y2, y3, what is the formula of centroid, guys? So centroid formula is x1 plus x2 plus x3 divided by 3, comma y1 plus y2 plus y3 divided by 3. That is the formula of centroid. So using these centroid calculations, first we need to understand the centroid point, and next using the similarity measure, that is Euclidean distance or any other similarity measure, you need to identify whether that particular data point belong to that cluster or not. Okay, that's how you need to apply the concept of clustering or the payments concept to the real world data set. Okay, yeah. So uh, moving ahead, yeah. Okay, so so as we discussed, clustering basically is a unsupervised machine learning concept. So k-means clustering also comes under unsupervised learning algorithm. Okay, so talking about the definition for k-means clustering, it is an iterative algorithm that divides the unlabeled dataset into k different clusters in such a way that each dataset belongs to only one group that has similar properties. So at the initial hard clustering only, we have made this point clear that each data point should belong to only one cluster which has similar properties, right? So k-means follows the principle, because you need to follow a number of iterations to understand the concept. It is an iterative algorithm that that divides the unlabeled data set. So you need to follow this particular step. So whenever an unlabeled data set is given to us, k-means will try to iterate the algorithm which will divide the data into k different clusters. The k value is dependent on the type of data set what you're having and the size of data set what is having. Okay, yeah. So I would like to take you to a small video where we'll be understanding the concept of k-means. Okay, just a minute. Yeah, if you're having a look at this particular video, here we are having n is equal to 1000, which are number of data points, and k is equal to 5, that is number of clusters we want to form for this 1000 data points. And you can see I'm applying k-means clustering concept, and here iteration start with 0. So once I start this process, so let's see how actually this what happens to this video. Yeah, here you can see for number of iterations. Yes. So previously, you can see for k is equal to 5, you can see you are having 5, 1, 2, 3, 4, 5, 5 clusters, right? So here you can see at the middle, there is a centroid representation. All data points uh, are directed to the center because that is a centroid value. The distance between the centroid and that data point will be calculated. Okay. So here you can see if I take k is equal to 5 for 1000 data points, I'm having 30 iterations. Now we will try to look into for the same set of points. If I take k is equal to 10, what will happen? Let's have a look at this. Yeah, k is equal to 10. See how many iterations we will get. Yeah, 36 iterations. So for k is equal to 10, I am having 36 iterations. So this is how K-means clustering will try to do number of iterations, and at whichever point you're getting better result, that will be taken into consideration, right? Now you can see k is equal to 20. How many iterations are there? 26 only. For as I am improving the number of clusters, the number of iterations may decrease. Okay, yeah. Now I have increased the points to n is equal to 5,000. Now from 1,000 we have moved to 5,000 with different k values. Now just have a look at that iterations and number of clusters which you are going to have. Now k is equal to 10. Let's see how many iterations. It's around 20, 30, 42 iterations. Next k equal to 20. How many iterations we have? Around 37. Now I'm going for 10,000 attributes. Likewise, for different attributes, for different cluster k values, we need to calculate the centroid values, and for number of iterations we need to look into, and accordingly this k-means algorithm will try to relocate how many clustering values are available. Fine. Yeah, I hope this video will make you understand clearly what actually is the k-means clustering, how it is being happened. So how to go with the number of values of k, these all things we will look in the further slides. As of now, I want everybody of you to make this small understanding or the pictorial understanding very clearly. And number of clusters k is equal to 20. How a centroid is represented here, how distance is calculated. These all things we need to have a clear understanding. Okay, yeah. So have a look at this representation first. Yeah, this process continues with different values. Okay, yeah. So this is the video link which I have posted here, from where we have taken this video. So this is also shared in the classroom, so you can verify it later, you can watch it later. Okay, yeah. So that video made us understand, or we had a just glance that how actually k-means process continues. Okay, so we'll be calculating centroid value, and from the centroid of each cluster the distance will be calculated to the data point, and whichever the point is nearing to that cluster, that will be moved on to that cluster. That's how k-means algorithm will be implemented. Okay, so in previous session we have discussed about what is good clustering. A good clustering should always have high intra-class similarity and low inter-class similarity. So similarly, k-means algorithm also follows the same principle. It classifies objects into multiple groups, that is we call it as clusters, such that objects within the same cluster should have high intra-class similarity, whereas objects from different clusters should have low interclass similarity. I'll just take you to that particular slide to make you understand what is interclass similarity and what is intra-class similarity. So this picture can uh, make you understand what is interclass similarity and what is intra-class similarity. Fine. Interclass similarity means similarity between the data points inside the cluster, and intra-class similarity is nothing but outside the cluster there will be a similarity. Okay, yeah. So intra-class similarity means distance between the same cluster points, and interclass similarity is distance between different cluster points. Fine, yeah. So talking about our algorithm, yeah. So it follows the same principle of for which we are classifying it into a good clustering. So in k-means clustering, each cluster is represented by its center, that's called as centroid, which corresponds to the mean of points assigned to the cluster. Yeah, that's what we have seen in the video. Also, how centroid calculation will helpful for designing a particular cluster. Fine. So this is a flowchart representation to understand the concept of clustering. Okay, or k-means clustering. So have a look at this flowchart here. So initially we will take a small data set, input number of clusters. So we need to say at the beginning only how many clusters you want to find. So because the name says k-means, k indicates number of clusters. For example, if I say k value is equal to 5. So which means we want 5 clusters. Okay. Next, we will calculate the centroid values. So how to calculate centroid values? What is the formula? As I said, if you're having 3 points, x1, x2, x3, and y1, y2, y3, the formula of centroid is x1 plus x2 plus x3 divided by 3, comma y1 plus y2 plus y3 divided by 3. That's how we compute the centroid formula. Okay, so we will calculate centroid values and we'll keep it in the second step. And next, we'll calculate the distance between data points and the centroid values. So whichever the value or the distance value computed is minimum, that will be moved on into the cluster. And from there, we need to again calculate the centroid values until we reach the final destination. So the same process, whatever is indicated here, we will try to understand it in the further slides with a small example. Okay. Yeah. So moving ahead with the k-means algorithm. So here is the algorithm or the step-by-step representation of how do we compute the k-means algorithm. So here we have seen the flowchart representation of the k-means algorithm. Now we will try to understand it step by step in the same manner how we have understood here. So initially, as we have discussed, we need to specify the value of k, that is number of clusters need to be fixed at the initial stage. In the second step, so randomly select k data points as cluster centers. So which means you need to compute the centroid value. Okay, the centroid value should be computed randomly. So this is very, very important. So basically you will take some data points and you will calculate the centroid value. And in step 3, we'll calculate the distance between each data point and each cluster center or the centroid value. The distance may be calculated either using a Euclidean distance or Manhattan distance or cosine distance function. So you can use any other distance function, but in our examples, we'll try to go ahead with Euclidean distance concept. Okay. So once distance is calculated, so whichever the value which is nearest to the data point or which is very minimum, that value should be kept into that cluster. For example, if I am having 3 clusters, so if I am calculating distance value of particular point, if the distance value, the whatever the value you are getting, if that value is near to cluster 1, then that value will be kept in cluster 1, or else if it is near to cluster 3, it will be moved on to cluster 3. So according to the nearest distance of that particular data point to that cluster, we will try to keep that into particular value. Okay, again as we have said, if after that we will try to uh, again go back to the central calculation, because every time you insert a value into the cluster, you need to recompute the centroid values. Okay, the center of a cluster is computed by taking mean of all the data points contained in that cluster. So we will try to understand this in the example when we discuss about a particular data set. Okay. Yeah. So keep repeating the procedure from step 3 to step 5 until any of the following stopping criteria is met. So this process iterates. That's what we have seen in the video. There are a number of iterations. So until the process is completed, it will have iterations from step 3 to step 5. So once the ending or the criteria is met, we will stop the algorithm and we will be fixing the data points into a number of clusters. Okay. Yeah. Now we will try to explain the same concept with a small example here. So the questions in examinations will be asked something like this: apply k-means clustering for the below data set for 2 clusters. So which means here the k value should be equal to 2. So that's what initially they are specifying. So k value should be equal to 2, and accordingly for this data set we need to tabulate all the assignments, which means how you are assigning particular value to cluster 1 and how you are assigning particular value to cluster 2. That should be tabulated at the end of this particular problem solving. Okay. Yeah, this is how questions will be asked. And now if you are looking at that data set here, you are having 6 samples only. So we have taken only 6 samples to make the concept clear, but in real time you will be having the same set of points with more values. For the process, whatever we are doing will be same, however, for every data point. Okay, so initially you can see there are points called as x comma y, 185, 72, 170, 56. Likewise, you are having data points. So these data points are very crucial for us to compute the algorithm. And you can see here, you don't know what is x and what is y. So there is no label. So what does this, whether it belongs to height or weight, nothing is mentioned here. Only based on data points, without any labels, we are going to compute the algorithm. So the steps, whatever we have discussed now, we'll be following here. So the first step is already done. That is, the k value is equal to 2, which is given in the question only. Okay. Now, moving ahead, yeah. So we should calculate the centroid value. So how centroid values are taken? As we said here, centroid values are taken randomly. Randomly select any k data points as cluster centers. So from these given data points, we can randomly take the values as centroid values. So what we are taking, the first value, that is 185 comma 72, is taken as first centroid value, and next 170 and 56 are taken as second centroid value. That is cluster 1 k1 and k2 is the cluster 2. Next, we'll be trying to calculate the centroid, the Euclidean distance values. So the formula for Euclidean distance is what we have said. So now we need to calculate the centroid values of each and every data point. Here data point is the row values, whatever we are seeing. 185 comma 72, 172 comma 170 comma 56, 168 comma 60. So for each data point from 1 to all the points, we need to calculate the distance values. Now we'll go ahead with the step 3, that is distance calculation. So the cluster values are, for the cluster 1, 185 comma 72, and with this 185 comma 72, we need to calculate with the centroid values. Centroid values are 185 comma 72 and 170 comma 56. So now for the cluster 1, you can see the value is equal to 0. Why? Because the same points are taken. Because randomly I have selected the first point as the cluster point. If I calculate this cluster distance between the cluster 1 of that particular point with the same point, distance will be equal to 0. That's why 185 minus 185 is equal to 0, is the result is also equal to 0. Next, distance from cluster 2. The cluster 2 values are 170 comma 56. Yeah, that's what we have kept here. So 170 comma 56, distance from 170 comma 56 to 185 comma 172. So the value is 21.93. So obviously the lesser value is 0, so it is a cluster 1 value. Similarly, now I'll go with the next data point, that is, yeah, 185 comma 72 with 170 comma 56. So yeah, for cluster 2 this value is equal to 0, and here you are having 21.93. Fine. So now if I say, because the lesser value is here is 0, here the value of k1 belongs to, this point belong to cluster 1, and this point belong to cluster 2. So initially there is no need to confuse here. We are trying to compute the distance between these points only, the centroid values only. Okay, now we'll be having a clear understanding. Now I'm going with the third data point, that is 168 comma 60. Now 168 comma 60 distance should be computed with cluster 1 k1, that is 185 comma 72, and 168 comma 60 distance should be calculated with cluster 2, that is 170 comma 56. Okay, I'll try to show you the same thing here. Okay, now you can see the new point, that is 168 comma 60. Whenever it is computed with the distance from cluster 1, the result is 20.808. The formula, distance formula is same for every calculation. That's what we call it as iteration in the algorithm. That is, for every iteration distance values will be computed, and you can see the same data point 168 comma 60 is again calculated with cluster 2, 170 comma 56. So the result here you can see, for cluster 1 it is 20.808, and for cluster 2 4.472. If I tabulate these values here, 20.808 and 4.472, here you can see the lesser value is 4.472. That's what we have discussed here. So according to the algorithm, what it is saying, yeah, the center a data point is assigned to the cluster whose center is nearest to the data point. That means among the calculated values, whichever value is lesser, that value, that cluster value will be assigned here. That is, this data point belong to cluster 2 only, because in cluster 2 only we are having the less value. Now because cluster 2 value is updated, we need to update the centroid value of cluster. So how to update centroid value? That is by calculating the mean. So how to calculate the mean? So mean should be calculated with the old cluster value. The old cluster value is 170 comma 56, right? Yeah, what's the old value? It is 170 56, and the new cluster value should be the value whatever we got here, that is 168 comma 60. So if I take mean of these values, I am getting a new point, or the new centroid value. The next cluster values of cluster 2 should be having this value, that is 169 comma 58. Okay, yeah. So moving ahead, now I'll go with the fourth value. That is, the fourth value is 179 comma 68 as given in the data set. Now 179 comma 68 value distance should be computed with 185 comma 72 and cluster 2 value. The cluster 2 value of second cluster is not 172 comma 56, sorry, 170 comma 56. Now it is being changed. Now what is the new updated value of cluster 2? It is 169 comma 58. Okay, that's why you can see for cluster 1, when I compute the distance, it is 7.21. Next, if I calculate the values, now you can see for this new point 179 comma 68, and now you can see the cluster 2 values are 169 comma 58, which is the new updated centroid value. Okay, so whenever you're getting particular point into a cluster, the centroid values need to be updated. So now if you're tabulating these values, the result is 7.211 and 14.14. So you can see the cluster 1 value is minimum. That's why 179 comma 68 belong to cluster 1. Okay, now again you can see, because this value belong to cluster 1, the cluster 1 values, centroid values need to be updated. So again, taking the mean, you'll be getting new centroid value for cluster 1. So this happens until all the data set values are updated. Now I'll be taking you to the next data point. That is, new data point is 182 comma 72. So now 182 comma 72 values are now computed with new centroid value, that is 182 comma 70. Now the distance value obtained is equal to 2, and now I'll try to compute the same with the cluster 2 values, centroid values, that is 169 comma 58. I got the distance as 19.10. If I tabulate these values, I'm getting something around cluster 1 value is equal to 2 and cluster 2 value is equal to 19.10. This is a very big value. So obviously we can see, or we can say, the value of 2 is less than 19.10. So this value belong to cluster 1. So again, the centroid value need to be updated for cluster 1. So every time a data point comes into a cluster, then its centroid value should be updated. Likewise, again, if I go for a new value 188 comma 77, so again we calculate the distance from the new centroid value of cluster 1 and cluster 2, and we will be trying to assign it into either of the cluster. So finally we can see the assignments here. This is what which is asked in the question. Tabulate the assignment values. That means according to the data point into which cluster it belongs to. Now you can see cluster 1 is having 4 values and cluster 2 is having only 2 data points. So you can see 170 comma 56 and 168 comma 60 belong to cluster 2, and the rest of the data points belongs to cluster 1. Likewise, if you are having more values, we can try to compute the distance values and update the centroid values, and thus we can form the clusters. Okay, yeah, this is the concept of k-means algorithm. Okay,